Now that we've looked at variables and the kinds of data that we can get, we want to start moving into getting knowledge from this data, turning that information into knowledge. And the first step in this is to summarize the data. And I want to start by just showing you, you're not supposed to be able to read this, but this is actually sort of a shrunk down version of a table of data that I've collected from students over a couple of semesters. So this is 370 different students, and I've asked them 21 different questions about themselves and recorded their answers here. And you can see that it's this is actually about a third of that data. The first 100 or so lines, and this demonstrates the fact that, look, there's all this information. How am I going to make sense of it? And the answer is, well, let's first focus on one variable. And I had, as I mentioned, 21 here. So over here to the right is a column, and if I zoom in on that, we see that that's the fave color. So the favorite color column. The students are all asked, what's your favorite color? And so they responded, and I've recorded their responses there. So now I've focused down, and but I still have the problem that there's lots of information here, and maybe I can tell some things from looking down the column, like blue seems to be very popular, but what's the second most popular color? It's not really clear from here. Green shows up a lot, as does yellow. Well, I guess red, and and even blue is questionable because maybe it's just the first few rows. So what I need to do is look at this variable fave color and see if I can pull out what's going on with this data set. So indeed, what I'm going to do is make piles. That is, I'm going to record how often blue was mentioned by a student. So I'll make a little table like this one where I have counted up in for each of the different color answers how many students gave that color as their favorite. So you can see at the top there were 14 that said black was their favorite color, and 129 said that was blue were their favorite color, and so clearly blue is pretty much a runaway winner. But green 88, and if I look down the column, yeah, 88 is the second most after blue, so green is the second most favorite color. And then gray and orange and so forth, right? And let's go to red because that's the third favorite color at 51. So I can see that by take that long column of information and turn that into some knowledge about, well, what was the number one answer, what was the number two answer, and actually, by the way, I could also look at the least favorite colors, I guess, is white. Only one person said white, and two people said silver, and so that's not very interesting. You do also notice that there is the 366 total students that were surveyed, and I had told you there were 370 students. It turns out that 4 of the students gave answers that didn't have an answer for their favorite color, and so they have been left out of this table. Great, so I've summarized the data, but there's actually another way I could summarize this, and that is, let me just mention that this would be called a frequency of the color, because to a statistician, frequency means count. So I have counted up the colors and told you how many were each. So the second way to look at the data would be to actually calculate percentages. That is, tell you, that so many had black, but it was 3.8% of the students that I asked that said black was their favorite color, and an overwhelming 35.2% said blue was their favorite color. So I can get these percentages, and when statisticians talk about percentages, they talk about relative frequency for that variable. And so we can see that. You notice that actually the same conclusions hold up. Blue is number 1, green is number 2, red is number 3, and white, yeah, is at a 0.3% is the least popular. So the percentages or counts seem to give me the same information. But there are some cases where percentages are a little bit more useful. So for example, what if I had some friend who was teaching a statistics class at some other university, and he decided to ask his students what their favorite colors were. And so he came back and he told me, oh, look, 87 of my students said blue was their favorite color. And I look over in mine and say, oh, well, I had 129. So, your students for some reason don't like blue very much. And we'd have a big argument about, why that was, why UD students like blue more than other students. But in the end, it turns out that, I remember that I had 366 students, and then he tells me, oh, I had only 250. Oh, that's the difference. The 129 and 87, those aren't directly comparable, 129, 87. So what I need to do is compute percentages. That is, out of 129, out of 366, what is 129? And out of 250, what is 87? And it turns out, with a little arithmetic, right? We saw this number before. 35.2% of UD students like blue, and at his university, 87 out of 250 turns out to be 34.8%. Which is basically the same percentage as about 35% in each of the universities. So it turns out that the two universities are very similar, but the only way to see this is to compare their percentages. So this is why percentages are preferred when I'm making comparisons between groups. And we'll see this again. Now, the tables we've been looking at are called distributions by statisticians. We actually talk about the frequency distribution and the relative frequency distribution of a particular variable. And this is a really important concept. This notion of distribution is a very important concept in statistics. So I want to formally define it. A distribution of a categorical variable, and we'll find out that quantitative variables have a similar definition. The distribution of a categorical variable is two things. One is all the possible outcomes of that variable. So you have to list all the possible outcomes, as we did, all the possible colors that were answered, and then how often each outcome occurs, either in counts or percentages. Okay? And this is fundamental to statistics. It's seen again and again throughout statistical practice up to the highest levels. Statisticians talk to each other about distributions. So one possibility is I might ask you, what is the relative frequency distribution of fave color? And you need to learn to parse this sentence. And the place you should start, your eye should start, is on this notion of distribution of favorite color. Because what that says is, okay, well, I'm going to look at the favorite color column, and I'm going to first write down all of the possible colors that were answered. So black, blue, green, gray, so forth and so on. So I write those all down, figure those out, right? And then, going back to the question, what is the relative frequency distribution? We should focus on the relative frequency part. What that tells me is that I need to report percentages because it's relative frequency. And so in addition to this table, I will write down the column of percentages, right? And then have a nice total at the bottom to show that, these add up to 100%. That will help later. So I want to go to two special cases where students seem to get confused a little bit when I ask these kinds of questions. So sometimes I will ask a question like this, where I did collect data from students in my classes about whether or not they live in the dorm. And so I'll say, well, here's the data. Compute the frequency distribution of lives in dorm. What does that mean? Well, again, it's a distribution of lives in dorm, so I'll look at the column and I'll notice the possible answers are yes and no. There doesn't seem to be any other answers, right? And so the first thing I need to do is establish that, right? I will put down a column and I'll say, well, some answered no and some answered yes. And And then I will, because it says a frequency distribution, I know what I want is counts. I'll count up the number of no's and the number of yeses and put those, corresponding. So there were 105 that said no, they don't live in the dorm, and 265 that said yes, they live in the dorm. And you notice that totals up to 370, and I put that down there at the bottom to help guide somebody who's looking at this data. Another special case could be found if I were to look at the relative frequency distribution of living, which is a funny variable. I called it living living arrangements or something like that. So we called it living. And you can see that what it is actually a little bit more detailed. Do you live in Madonna? Do you live in at home? Do you live in Jerome? Do you live in Tower Village? So forth and so on. So this is some detail. And so I look at the question, it's relative frequency distribution of living. So the first thing I need to do is establish all the possible answers. So you see Augustine, Catherine, Gregory, Jerome, Madonna, so forth and so on, right? And then because it's asking for a relative frequency, that means what I'll do is I'll calculate what percentage said they live in Augustine, what percentage said they live in Catherine, so forth and so on. So there's my percentages. Okay. Now the reason that seems like just like what we did, the reason this is a special case is because Catherine actually, if you notice, is 0%. Well, it turns out Catherine is a dorm here on campus, or was a dorm, I should say. It's being used as an office building right now. But in the past, Catherine was a possible answer. And so I actually pulled out of my history and my memory that Catherine was one of the possibilities for answering, and I put that down as one of the list of possible living arrangements. It turns out that nobody lives in Catherine, but that doesn't mean that I should leave that out of my table. It's a bit of a judgment call. I actually had to add that in some sense manually to make sure it was listed, but that might be something that's useful to somebody who is interested in the history of the university. It used to be that a lot of people lived in Catherine. Now nobody does, and this table expresses the fact that nobody does. So we have to think a little bit about the possibilities when I say, give me a distribution. In the yes/no case, will tell me all those possibilities, yeses and nos. And in other cases, if there are other possibilities that seem relevant, then list those as well. Just putting 0% or 0 count on each of those. Now here's another little tip. It turns out that sometimes we have too many levels, and this actually happened when I collected data about the favorite colors, because you can see, so I've now included a second column. I've got the fave color column, but I've got the fave color original, or orig for original. And these were the actual answers that students gave me. And you notice that there was still a lot of blues, but there were also some people who answered things like periwinkle blue and navy blue, which are wonderful colors, right? But the problem is if I used everybody's own individual, special color, I would have this table that would be, hundreds of lines long, and it gets a little overwhelming. So what I did is I reclassified some things, gathered some of these colors together into groups that were a little bit more broad, so that I wouldn't have quite so many levels or categories. So the periwinkle blue I did this manually. I had to clean this up as blue, and navy blue is turned into blue, and so I got answers that were in just a few, what was it, a dozen or so color categories, so that it would make the analysis a little bit more reasonable.